The first thing we want to start off is introducing you to the commandlet select-object. Select-object can be used to display specific properties from the objects and will return them to the screen. You can use it to list only unique objects instead of listing specific properties. You can also use it to expand a specific property if it contains other values within an array or a hash table. But the real important part about this lesson is introducing you to calculated columns. Calculated columns are going to give you the ability to create a custom property dynamically whenever the command is executed. You can choose the label and the contents of that calculated column. It's created by using a hash table. A hash table is made up of a key, which is going to be your label, which then is displayed as the property's name, and an expression value, which is the calculation that will then be displayed in the property's content. Let's take a look at hash tables and how they are made. You're going to store one or more key/value pairs. The key and value pair are going to be separated on a per line basis, or it could be on the same line as long as you include a semicolon. You can use N to represent the label to save you from typing longer names, and E to represent expression. Let's take a look at this on an example where I'm using multiple lines. Notice that I still have to specify my semicolon between the label line and the expression line. Notice that there is an @ sign followed by curly brackets to represent you're starting a hash table and then closing the curly bracket at the end. Also notice that the label is a standard string. The expression, however, is represented by using a code block. This is what is going to set the value of the expression. In this case, we are only going to set the value of status, and we are using this to basically rename status to service state. Let's take a look at examples of select object with calculated columns. In this example, we are going to retrieve services with the status column being labeled as service state. Like I had said, we are using this calculated column to rename the status column. You can also perform math on a calculated column. This is going to be more of the common use of calculated columns, is to perform a certain expression. In this example, we are getting the process of Excel. We are then going to select an object of process name, and then we are going to create a new calculated column with the name of virtual memory MB, which represents megabytes. In the expression, we are taking the virtual memory, or the VM property, and dividing it by 1 megabyte so that it is displayed in megabytes. Let's jump into a demonstration of working with select object and creating calculated columns. For this demonstration, we are going to use Windows PowerShell on DC1. Now that we've launched Windows PowerShell, we're going to run a command that is fairly familiar to us already, get-service, which by default returns to us the current status, the service name, and the display name of the services. But I only really care about the name and the current status. So I'm going to use the select object commandlet and type in the property name and status. And what this is returning to me is the service name and the current status of that service, and it is excluding the display name from the results that are returned to the screen. Now let's go take a look at another commandlet that we are very familiar with, the get-process commandlet. And on this one, I only want to see the name of the current processes that are running. So I can type in process name, and it's going to list the names of the processes that are currently running. Let's take this a step further, and instead of it listing CSRSS and SVC host multiple times, let's add a parameter named unique, and it will actually remove those for us. So we only have one value of each process currently running. Now we can take this even further. Let's take a look at the process name and the property modules. And you're going to see the property modules actually contains an array that has information in it. So instead of seeing that array, let's use the parameter expand property, and now specify modules. Now when we run this, you'll see there's a couple errors that pop up throughout the way while it's enumerating this, but overall, we've enumerated all the modules now that are running on a per service basis. This is just a simple example of using expand property, but in some cases you may need to run that so you can see all of the values within the array of a property. Let's try creating a calculated column off of this. I want to get the processes that are running, and I want to select the process name, and I want to create a calculated column. To create a calculated column, remember that you have to create a hash table. So I'm starting it with an @ sign and an open curly brace. And I am using the in to represent the label, and I am setting that equal to virtual memory MB. So I can see the virtual memory in megabytes. And then I am putting in the semicolon to represent a line break between these two values, and E represents the expression. The expression is going to be equal to another code block, so I need to do another curly brace. This time I'm going to do the current item, which is the underscore variable, in the VM property, and I'm going to divide that by 1 megabyte. And I need to close the curly brace for the expression and also the curly brace for the hash table. When I run this, you're going to see that these processes are consuming that many megabytes of virtual memory. Let's go another step further. Do you recall the student scores variable we were working with previously? Well, we need to create that again. And let's go ahead and set that equal to an import of the CSV that's located under the Posh folder. Now we can see student scores contains the different students' test scores. Let's take that variable and let's pipe that to a select statement. Now I actually want to see all of the information, so I am going to select all. But I'm also going to create a calculated column. So I'm creating the hash table. The label is going to be equal to final score, and the expression is actually going to calculate their final score for the class. So in the expression, I need to use another curly brace, and this is going to be a fairly advanced way of writing it. I am going to cast what type of variable these are, otherwise it reads them as a string and it will not work. So I am forcing it to think of this as an integer. And then I just have to represent the current object, test1, plus the current object, test2, plus the current object, test3. I'm adding those together, and I've got to close the parentheses. I placed all of those in parentheses so that it performs those calculations first. Very similar to middle school math, where you use parentheses to perform that operation before you perform the things outside of the parentheses. Now that we are going to be adding those test scores first, we also need to divide those by 3, since that's how many tests they took. We will then close the expression code block and also close the hash table. And now we can see everyone's final score listed here. We can see Brian Archer passed with an 84. Now James Patel passed with a 98.3 repeating score, and it just calculated everyone's final score for us.